Hi everyone. So we are Group 1. So today we are here to do the presentation about the topic Foxconn Indian iPhone factory proposal. Um, so these are the team members: Anjali, Lejin, myself Silpa, Rajesh, Monish, and Manoj. So just now we can go to the overview of our project. Uh, so today we are here to talking about the project with the Foxconn. Foxconn has been chosen to grow his iPhone manufacturing in India. So this is a part of a big government plan that offers 6.6 billion in support to increase local production. Our team of six was given this task to create a full plan of this new setup. So we look at where the best place in India that would be built, the factory. We also designed how the production floor should be laid out and made sure the plan meets the Apple's high standard of quality and safety. To make the smart decision, we studied Foxconn's past production data and check smartphone demand in India. So this help us to figure out how the workers and missions will be uh, needed and how the factories can grow the overtime. So now let's look why India is a great place for this place. India is the second biggest smartphone market in this world with over 600 million users, and that the numbers is growing fast. The Make in India program and the 6.6 billion incentive and are now expected to really help iPhone production grow locally. So as you can see in the chart, iPhone demand in India is growing up each year. This is the greatest chance for Foxconn to grow its business and help meet the demand by building and expanding the factory in India.
Hi. This slide provides a detailed overview of the individual work elements involved in the iPhone production, including the task description sequence and the associated cycle time. And it all also includes each work elements represent a distinct operation or process step grouped and analyzed by the historical cycle time performance. And the following key elements were assigned and grouped into 17 workstations based on the cumulative task and the balancing requirements. And additionally, a precedent diagram was developed in order to identify the dependency and in order to ensure the proper sequencing. And finally, the precedent relationship, ensuring that each task is only performed to ensure that each task is only performed once we have developed a precedence relationship. And on coming to the next slide, we do have the work elements and the precedents. So these are the tabulated representation of the iPhone production standard, and it includes the elements, the work element description, the precedence, and the task time. So actually, we do have from A to double O elements and the precedence and the task time for the based on the work element descriptions. We have calculated the task time.
So if you see the tag time calculation, initially we have taken 5 years as the demand based on the future demand given, and we have calculated the tag time with a slot like it has to be taken 12 months per year, 4 weeks per month, and 5 days per week, and 22.5 hours per day. So the total demand for 5 years calculated is the given number, and we have got the tag time as 0.383 minutes per unit, and based on that, we have calculated the theoretical workstation minimum needed, which is 1269. And if you see the precedence diagram, we have got this precedence diagram based on the takt time for each workstation. And based on that, we have linked the workstation with their idle time. And we have balanced the total production among all these workstations. And if you see the line balancing table, we have taken workstations of 1 to 1283, and we have grouped the workstation so that the takt time and the idle time gets balanced, so that all the works takes place in a right time and the production have a even flow. So this is the workstation with the assigned work elements and the work element time and the cumulative time and the idle time, and we have got all the workstations grouped together like 1 to 28 initially, like 29 to 75, 76 to 119. So these are the grouping of the workstations to complete our project based on the takt time.
Thank you, Manoj. I'll take it from here. Next slide, please. So with the calculation of the line efficiency, the given total task time was 485.88, and the number of workstations we have is 1285. And the takt time is 0.383 minutes. So if we apply the line efficiency formula, we are getting the line efficiency as 98.72. And the next slide, please. The location that we choose for this project is Oragadam Industrial Corridor, Chennai, which is located very near to the Chennai port. I think it's within 80 kilometers, and the airport comes under less than 50 kilometers, and it also has the access to the NH32, which connects to the southern part of the India, and NH48, which goes until Delhi in through the north side of the India. And it's already been home for many industries like Samsung, Dell, and Nokia, so that it ensures the supply chain availability. And we have a bunch of skilled and semi-skilled laborers, and from the engineering colleges and diploma polytechnic, we have a bunch of talents. And we have the utilities like reliable powers, water waste management, supported by the Tamil Nadu Corporation. And it also offers us excellent logistic infrastructures for both exports and importing the finished products. And also we have the land for manufacturing electronics with the tax and regulatory benefits as well, which is very excellent. And the area supports scalability for year 5 demand without the need for relocation or rebuild. The link for the given location is within the PPT for your reference. Thank you.
Hi all. So this is our factory layout. So here you can see we have given all the required areas that are necessary for a plant, and we have arranged all these areas as per the priority matrix. And I will give a brief review about our plant. You can see the material will be received at the receiving door. From there, all the raw materials will be either stored in the raw material storage or passed to sorting area. From there, it will go to assembly line. Once the assembly is finished, it will move on to inspection area, then packing area. And once the packing is done, it will be go on to shipping area, and it will be dispatched to customers. Also, with this, we have also given office rooms, conference rooms, cafeteria, and locker rooms, all that are required for the workers as well as leaders who will be working in this factory. Next slide. So this is our assembly assembly line floor plan. You can see all the workstations are given here, from starting from workstation 1 to 1285. All are arranged here in which the process operates. Also we have grouped all the workstations as per the line balancing diagram, line balancing table, which Manoj has explained earlier.
Thank you, Vijay. I will take it from here. So the proposed Foxconn facility in Oragadam, Chennai is strategically designed to scale production from 6 million units in year 1 to 16 million units by year 5 years, reflecting a 167% demand growth. To achieve this layout incorporates modular 17 workstation assembly lines that can be easily replicated along with shared support zone size for future expression. A 20 to 30% space buffer ensures between seamless integration of new equipment and automation updates are planned at bottleneck sections. Additionally, the shift structure can be optimized from 2 to 3 shifts per day, without physical expansion. Next slide, please. In conclusion, the factory location offers excellent logistics, infrastructures, and access to skilled labor, making it deal for long-term growth. We recommend starting with one full assembly line, expanding to two by three, investing in ergonomic and automated solutions to reduce fatigue and cycle time, monitoring high load stations for bottlenecks, and collaborating with local institutes to build a skilled labor pipeline for sustainable operations. This is, this is our entire project. Thank you.
Thank you.